Multiplying and dividing real numbers. In the last section, we talked about adding and subtracting real numbers. In this section, we will work on the concepts behind multiplying and dividing real numbers, paying particular attention to integers. You probably already know that 5 times a negative 4 is equal to a negative 20. The question is, why? Well, there are several reasons that we could talk about. One reason, 5 times a negative 4, means that you have negative 4 5 times, and you are adding all those up. And because of what we did in the last section, a negative plus a negative plus a negative plus a negative plus a negative would still give you a negative, so my answer to that would be a negative 20. We could look at it, though, another way by setting up a pattern. So I'm going to set up a pattern here, and I have 5 times 4, 5 times 3, 5 times 2, 5 times 1, and 5 times 0. And you can tell by looking at this that in every single case, the first number is the same, and the second number in each one of those multiplication problems, I am decreasing by 1. So when I do that, I get answers 20, 15, 10, 5, and 0. The answers every time I am subtracting 5 every time because I am reducing one of the numbers I am multiplying, that second number. If I continue with that same pattern, I'm going to have 5 times a negative 1, 5 times a negative 2, 5 times a negative 3, 5 times a negative 4. Well, the pattern needs to continue. I need to continue decreasing by 5 every time. So this answer would be a negative 5, this answer would be a negative 10, this answer would be a negative 15, this answer would be a negative 20. What I have is I have a positive times a negative. So a positive multiplied, I'm going to use a dot for that multiplication sign, a positive multiplied by a negative gives me a negative answer. And as you can see, for all of these problems, I have a positive times a negative. In every case, my answer is a negative. So what is a negative times a negative equal to? Let's set up another pattern to find out. I'm going to do the same thing. I'm going to have a negative 4 times 5, and every time my first number is going to stay exactly the same, and I'm going to reduce my second number by 1. So you can see I'm once again just setting up a pattern. Based on what we just talked about last time, we know that negative 4 times 5, because I have a negative times a positive, has to give me a negative. Negative 4 times 4 would have to give me a negative 16. Negative 4 times 3 would have to give me a negative 12. And I'll continue writing down these answers as you look at them. What happens this time to all of the answers? This time you can see that all of the answers to get from negative 20 to negative 16, I'm actually adding 4. So I'm actually adding 4 every single time to get from one answer to the next answer. Well, the pattern does have to continue again. So I'm going to go negative 4 times a negative 1, and I'm going to have to add 4, which means that my answer would have to be a positive 4. Negative 4 times a negative 2. Once again, I'm going to have to add another 4 to that 4, so I will get an answer of a positive 8. So we can see that a negative times a negative gives me a positive. There's an understood positive sign with that 8. So once again, a negative times a negative is going to be equal to a positive. We can put these ideas then into two different rules for multiplying two real numbers. First of all, if the signs are the same, the answer is always positive. And the second rule, if the signs are different, the answer is always negative. Remember, these rules work if you are multiplying two real numbers. But how about if you are multiplying three real numbers, like -2 times -3 times -4? The signs are all the same. But what's the answer to the problem? To do that, you just need to do it in steps. -2 times -3, I have the signs the same, so that must give me a positive, so it would be a +6. So now I have 6 times a -4. The signs are different, so 6 times -4 is equal to a -24. Just remember that these rules work for multiplying two real numbers. They actually work for multiplying an even number of real numbers. They will always work. If it's an odd number of numbers that you are multiplying, then these rules will not work. How about the rules for division? Since multiplication and division are opposite, are the rules opposite? Well, let's take a look and see. If I have 20 divided by 4, I have two positive numbers. Well, you know that 20 divided by 4 gives you just a +5. The signs are the same in the division problem, and I got a positive answer. How about 20 divided by a -4? If I have 20 divided by -4, if I want to figure out what that answer is, I know that that answer times a -4 has to give me 20. Well, that would have to be -5, because -4 times -5 would give me a +20. So, as I take a look at this, I am dividing. The signs are different. One is a positive, one is a negative, and I get a negative answer. So when the signs are different, I get a negative. Let's look at one more possibility. If I have -20 divided by a -4, what would that answer have to be? According to the rules of multiplication, as I go through and do that, I would have to end up getting a +5 for that answer, because a -4 times a +5 would give me that -20. So once again, I have a division problem. The signs are the same. They're both negative. I got a positive answer. So the rules for dividing are exactly the same as the rules for multiplying. If the signs are the same, the answer is positive. If the signs are different, the answer is negative. Another idea that we need to talk about is division with zeros. What is 0 divided by 6? We could set this up again as a multiplication problem if we wanted to. 0 divided by 6 is equal to something. And right now I have a box there, which means that something times 6 would have to equal 0. Well, the only way to get 0 when you multiply two numbers is for one of the numbers or both of the numbers to be equal to 0. So this answer would have to be a 0, so 0 divided by 6 is equal to 0. How about if you have 6 divided by 0? Well, let's go through and do the same thing. 6 divided by 0 is equal to my box, which means that my box times 0 would have to equal 6. What number, the question is, what number times 0 is equal to 6? Well, that's not possible. It's not possible to take a number multiplied by 0 and then it'll end up with 6. So we have an answer for this in math, and we say the answer is undefined. You can say the answer is undefined. You can say the answer is not possible. You can say there is no possible answer. Make sure you do not say that the answer is 0, because that is not true. The answer to this is undefined. Another idea to talk about in this section is the multiplicative inverse property, which states that the product of a number and its inverse is always equal to 1. Let me give you an example. If I have the fraction 2/3, the inverse of 2/3 just means to flip-flop the numerator and the denominator. So the inverse of 2/3 is equal to 3/2. If I multiply those two numbers together, 2/3 times 3/2, I'm going to get 2 times 3 is equal to 6, 3 times 2 is equal to 6. I get an answer of 1. Does this work with positive or with negative numbers as well as positive numbers? Let's do another one. If I have negative 3/4, the inverse of negative 3/4 is still a negative, but it's negative 4/3. So I'm going to multiply, and I have a negative 3 times a negative 4, which is a positive 12. 4 times 3, the denominators, 4 times 3 also gives me 12. 12 divided by 12 gives me 1. So it doesn't matter if I'm dealing with positive numbers or negative numbers. The product of a number and its inverse is always equal to 1. How about if you just have a number that's not a fraction, but you have just the whole number 6? What's the inverse of 6? Well, 6 can be written as a fraction. I could write it as 6/1. The inverse of 6/1 is 1/6. And once again, if I multiply those across, I do get 6/6, which is equal to 1. Since we are talking about multiplication with real numbers, we also need to mention exponents, since exponents are repeated multiplication of the same base. So if you have 2 to the 3rd power, the base is the 2. The 3 is known as the exponent. And what that means is to multiply that base 2 by itself 3 times. So 2 to the 3rd power is equal to 2 times 2 times 2, which is equal to 8. If I have negative 2 and I want to take that to the 3rd power, that means a negative 2 times a negative 2 times a negative 2. And once again, figuring that out, a negative times a negative gives me a positive. So this is a positive 4 times a negative 2. A positive times a negative gives me a negative. So this answer is equal to a negative 8. If I change this again and I have negative 2 to the 4th power, negative 2 to the 4th power means negative 2 times negative 2 times negative 2 times negative 2. And figuring that out once again, I have a negative times a negative, which is equal to a positive. Here I have another negative times a negative, which is also equal to a positive. So I have a positive times a positive, which is equal to 16. Notice that when I had a negative number, if a negative number is the base and the exponent is odd, I end up with a negative answer. If I have a negative number as the base with an even exponent, then I end up with a positive answer. I want to give you one other example, and I'm going to tell you that this example I'm going to show you is one of the areas that a lot of people make mistakes in. We just agreed that negative 2, and I put the negative 2 in parentheses to the 4th power, is equal to a positive 16. And what this means is negative 2 times negative 2 times negative 2 times negative 2. If the problem is written this way, though, notice I don't have parentheses around that negative 2. This is not negative 2 to the 4th power, what I have just written. This means 2 to the 4th power, and then I want the opposite of it. So this particular answer, 2 to the 4th power, is equal to 16, and then I want the opposite of that. So the answer to that problem is a negative 16. So once again, negative 2 in parentheses to the fourth power is equal to a positive 16. Negative 2, it's not actually a negative 2, it's 2 to the fourth, and the opposite of that is equal to a negative 16. Please be very careful with that. In the last part of this section, you will see problems that have addition, subtraction, multiplication, and division all together. As you are doing those types of problems, remember to follow the order of operation rules that you've talked about in a previous class. But I have those up at the top of this screen. Please excuse my dear Aunt Sally, and you are doing them in those 4 different steps. So, if you are given the problem negative 5 plus 2 times negative 3, the very first thing you need to do is the multiplication. So as I go through and do that, I'm going to do 2 times a negative 3 first of all. 2 times a negative 3 gives me a negative 6. And I have negative 5 plus a negative 6. I'm adding 2 negative numbers together, so the sign stays the same, and I end up with a final answer of negative 11. Another example would be negative 7 times, in parentheses, 3 plus a negative 6. In this particular problem, I'm going to do the parentheses first. 3 plus a negative 6 is equal to a negative 3. And then I need to multiply that times a negative 7. So I have negative 7 times a negative 3. A negative times a negative is going to give me a positive. So the final answer for that problem is 21. As I say, you need to just make sure that you follow all the rules for, please excuse my dear Aunt Sally, as you go through and do these problems. Let me do one more example. I have 36 divided by 4 times 3 subtract negative 5 squared. If I'm going to do that, the very first thing I need to do is I need to do my exponents. Now I see parentheses there, but the parentheses are not really a set of parentheses in this particular case. They're just telling you that I want the negative 5 squared. So that's really an exponent. So the very first thing I'm going to do is I'm going to go through and I am going to solve my parentheses. So negative 5 squared means negative 5 times negative 5. So that's giving me 25. And now I'm going to rewrite everything else that I have. 36 divided by 4 times 3 subtract 25. One of the bigger mistakes sometimes people make is in this next step. I have 36 divided by 4 times 3, and I have to do multiplication division first. But remember, I have to do them in order. So the very first thing I'm going to do is I'm going to do the 36 divided by 4. I'm not going to do the 4 times 3. 36 divided by 4 gives me a 9. So now I have 9 times 3 subtract 25. And then I'm going to go through and I am going to multiply the 9 times 3. 9 times 3 gives me a 27. 27 subtract 25 gives me a final answer for this of 2. As you are working through the homework for this section, please make sure you ask me if I can help you in any way.